making a plan to achieve them, and then executing. In general, the entire brain is like a center for rhythmic signals. So if we look at it from the perspective of using EEG, neurons and neuron groups are always firing in rhythms at different frequencies. Not just one, of course, but overlapping complex signals that might cycle higher or lower based on what you're doing. And so, kind of taking that into consideration, um, like external rhythm as well does engage and does entrain different neurons in the brain, whether that's not just the motor cortex, but also auditory, the visual cortex, um, many different places.
Thank you. So my second question for you was, you often describe rhythm processing as a form of predictive timing, and how does this perspective help us understand the role of the basal ganglia in rhythm and movement?
So when it comes to kind of this predictive timing, uh, let me ask a simple question first, which is how many beats does it take to detect a rhythm?
I'm not too sure, but I'm gonna guess 20.
That is good because you would think that, going for like dut, 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 but
Yeah.
actually it only takes two beats to detect the rhythm, the
Oh,
first
really?
and the second. As soon as when you hear a noise or a sound or see some kind of signal, that has already activated your brain because you've perceived it. A lot, depending on what it is, this could be similar to what we call like an oddball paradigm, something unexpected that causes a firing generally along the central axis of the brain. But then if it happens a second time, your brain is already starting to make predictions. It's like dut, dut, so you're already thinking ahead, like, is this going to be a rhythm or is it not? And if it's not just something simple like that, if you get signals in a row that might be not linearly interspersed with each other, but are like dot 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 dot, your brain is already thinking and processing, is there some sort of underlying pattern here? Or is it just random noise, which your brain will continue attempting to process into a rhythm or a pattern, just because um, the entire brain itself is like a pattern recognition system. So, given that, uh, where are we? Yeah, so you're asking about predictive timing and how does that help
Mhm.
us understand the role of the basal ganglia? So the basal ganglia itself, it's made up of several different distinct areas that are all in very close communication with each other. Um,
Yeah.
and they're also very highly integrated with other areas of the brain. So just to quickly go over these in a way that will kind of shape the rest of our discussion. So the basal ganglia itself, which is kind of deep in the brain, receives information from more foundational areas like the brainstem and the cerebellum, which are some of the oldest parts of our brain now, that have been very early on in evolution and have uh, continued developing with us as we evolve to, modern era, thousands of years. From the basal ganglia processing, it then communicates with motor areas. It connects to the prefrontal cortex. It connects to the limbic system, which are involved in all sorts of different things, not just movement, but also executive function and emotion and mood processing. So, because the basal ganglia is involved in kind of every step of the motor activity, from, like we said, from planning to organization of structure of movements in general to the actual execution. Uh, this predictive timing and this internal integrated timing is kind of integral to each part of that.
So you mentioned that it takes two beats for a rhythm to form in the brain, right? Is there any particular sound that like makes you think like generate that like rhythm detecting that then like helps your brain detect that it's a rhythm, or is it or like is there not like is there a particular kind of sound that you listen to that helps you detect a rhythm?
So, as far as um, information in general, like let's say you're walking through, a busy city street, there's a lot of different kinds of noise. It's not as if you'll be picking out patterns from within that constantly, but sometimes there might be something that stands out. But as far as something that might be interesting to hear, that we've done in some of our gait experiments, uh, is what types of sounds are best at making people kind of recognize and integrate a beat. Um, it is if if you had to choose between a high-pitched metronome and a low-pitched drum beat, which do you think is easier to walk to?
A low pitched drum beat.
Exactly. And that's the same in music all around the world, where it's the low pitches and kind of the constant beat that is driving more of these lower level systems. And in fact, it's easier for people to synchronize walking to a lower beat than a higher pitched one. So if you're thinking in terms of that, then yes, that range of auditory information is often easier for people to not just detect, but synchronize movements too.
Thank you. And so my third question was, how do rhythm and beat perception develop through learning and experience? And what does this suggest about how timing networks are organized in the brain?
Mm. Yeah. So the basal ganglia is also involved in um, learning as well. So it's involved in reinforcement training. So basically, the recognition and acceptance of reward versus essentially punishment that is going to inhibit certain movements. And this is not just learning from a teacher. This is moving into the world, like moving in the world itself. If you're doing an action, especially very early in development, even learning how to walk, your body and your brain are going to recognize, oh, if I move my leg this way at this time in this pattern and follow it up with a movement of the arm or the other leg, that's going to positively reinforce that training. But probably more to what you might be interested in, which is later on in life, um, you know, intentionally trying to learn something with a rhythm or a beat. Um, I think I mentioned this in the overall organization of the brain, where the very kind of fundamental and foundational beat perception is in the cerebellum. This is at, the millisecond level. So this is where a lot of the origin of uh, very low level, very fast timing comes from. And it is in this, back and forth communication with the basal ganglia, which is then communicating with motor areas like the premotor cortex, the supplementary motor area, the primary motor area. Uh, and all of this connection and communication is very integral with learning and developing skills. Uh, as far as um, individual differences, which I think you may ask about coming up, um, I'll kind of give a preview of that, which is to say that some people are naturally better at uh, detecting and learning rhythmic activities, but also that we have found through research that training and explicit learning are able to enhance these abilities. And it is something that you can train at and be better at that may help you uh, later on in life if you are afflicted with a disease or disorder that impacts these things.
Thank you so much. My next question for you was, in conditions that affect the basal ganglia, such as Parkinson's disease or stroke, what kind of rhythm or timing difficulties typically appear, and what do they reveal about brain disrupted networks?
Yeah, so one big focus in our lab is uh, the research of those with Parkinson's disease. So this is known as a hypokinesia disorder, which means very simply that it is a disorder of lessened motor and movement activity. So this affects things like your gait, your balance, and your motor execution. Uh, Essentially, things that can be affected are uh, this impairment of movement initiation, so beginning to walk or beginning to move, this lowering in the amplitude and velocity of movement. So if you're trying to take a large step, it will be more difficult for you. You might stumble or take a shorter step. Uh, it also expresses itself as muscular rigidity, so harder, so more difficult to make fluid motions, and also a resting tremor. So this, this shaking of your limbs, really. Uh, Research has found that generally this is due to lowered levels of dopamine in the basal ganglia. And because over time, if those neurons are getting less dopamine, their receptors will start to degrade, and this will begin to show these effects. Just to give you a number, because I reviewed a little bit before this, it seems that research has found that when roughly 30% of these neurons, these dopaminergic receptor neurons, are gone, that's when you'll start to see the effects of Parkinson's begin to occur. So, uh, let's see. Yeah, so what kind of difficulties appear? That's kind of what I discussed as well with movement and planning. There are also other effects in uh, facial expression, which often gets kind of what's plastic. It's difficult to make expressions, as well as general, lowering of mood. So even though we focus a lot on the motor and gait aspects of Parkinson's disease, there are a lot of other interrelated difficulties that these people may have.
Thank you. My next question for you was, when rhythm related networks are damaged, can other brain systems compensate for timing and beat perception, or are there limits to this, like ability to compensate or make up for?
So, yeah, this is also something that I learned very early on in high school as well, that the brain has a lot of plasticity, which means that uh, neurons are able to take on the role and responsibility of other areas of the brain under certain circumstances. Or speaking more generally, plasticity just means the ability of neurons to change, to form new synapses to call old ones that aren't being used so that they become more efficient. And it's really just the ability to learn, retain information, and do new things. Unfortunately, if kind of a full compensation was possible, then people would be able to recover from any disease or injury. But the truth of it is that based on the location of the damage and the extent of it, like the actual size, it may be difficult for areas of the brain to compensate for these highly specialized, highly connected areas of the brain. One area that is I suppose, more commonly known to be able to compensate and take over after injury is the sensory motor cortex. So if that those areas of the brain are injured in some way, then nearby neurons may be able to compensate over time. Uh, in the basal ganglia specifically, again, because it's highly specialized, because it's fairly small, and even within it, there are a lot of different highly specialized parts of the basal ganglia, like the putamen and the caudate, and the striata. Uh, this exact type of plasticity is somewhat more difficult, kind of, for the brain to do.
Is there any particular like does your age or sex or gender or anything play any role in disability to compensate? Does that have any effect?
Yeah, I would say that generally, age is a big factor. Uh, your brain, regardless of your age, is still plastic because you're still able to have memories, right? And memories are simply changes in the connections between our neurons in the brain that are forming whenever we're interacting with the world or thinking or taking in information. These are all forming new connections in our brain, no matter our age. However, it is true that as people age, some of this ability, this flexibility, does start to decline, which is seen in, a lot of different disorders like dementia or just general um, aging where, people slow down. Uh, it may be more difficult to remember things. So, in terms of recovery as well, uh, if you have, severe, late in life onset of Parkinson's, uh, the outcomes may be more difficult to deal with than if you have more early onset. Of course, that comes with its own difficulties as well, but it's something that we seek to find treatments for regardless of what stage of life you may be in.
Thank you. So my sixth question is, compared to other cognitive abilities, do rhythm and timing seem particularly resilient or vulnerable uh, after brain injury as opposed to other abilities, like your abilities to reason or your executive judgment and things like that?
Mm. Yeah, this is a little bit difficult to give like a very specific answer to because there's so many aspects of cognition and parts of our brain. There are very localized areas that can have really huge outsized effects on our daily life, such as the ability to speak, the ability to comprehend written or spoken language, which each of those are distinct parts of our cognition. It may be possible that due to an injury or stroke, you lose the ability to read, but you can still speak and listen and have no issue whatsoever. And there are other like very highly specific things that can happen in all areas of life. So to as far as timing and rhythm perception go, uh, on a daily basis, you might not necessarily need to be able to keep a beat. Like in most things that you're doing explicitly,
Yeah.
how often are you going to need to keep track of time in a very specific manner? But it's those related effects, related to the timing of movements, which affects gait and coordination and motor activity, which is how we interact with the world. Those can also be very kind of detrimental and have a significant impact on your daily life. And I guess just to mention as well, uh, many who have Parkinson's disease, it does affect a lot of aspects of your life, gait, and so on. Um, People are generally still able to walk, just it's impaired with shuffled gait, irregular gait, and usually higher susceptibility to falls, which can lead to further injury. But it's really all about uh, how you're able to treat these different you know injuries or diseases or
Yeah.
uh, disorders.
So my seventh question for you was, your work and the work of Dr. Gran has inspired interest in rhythmic cueing and music-based therapies. From the perspective of a neuroscientist such as yourself, when are rhythm-based approaches most likely to be effective when someone's recovering or in rehabilitation?
Hmm. So to for this specifically, just to go back a little bit to the beginning, so rhythmic auditory stimulation is a specific treatment that was developed by um, Dr. Thought et al. Starting in 1996. Um, and to explain to those who might be listening, this is a treatment in which music with a regular underlying beat is played while people are walking, either while just listening to it or told to explicitly synchronize their footsteps to the beat of the song. And what this does is essentially it circumvents some of the issues that are brought about by Parkinson's. So, if people are unable to generate and maintain a constant internal beat by having this external source of beat and rhythm come in, it's able to kind of go around those areas that are impaired and go straight to kind of the motor execution phase where people are able to see an improvement in gait parameters such as longer steps, faster steps, more stability, perhaps a wider step width, and so on. And so, with that said, if we know that music is able to help, um, a certain amount of people who are amenable to it, uh, my answer would be the same as in most of medicine, which is the earlier that you're able to begin rehabilitation and work on this, the better. Um, as soon as you're starting to see issues, listening to music, getting more involved in rhythm training may be able to help mitigate some of those effects and also help you later on throughout your life.
Thank you so much. So you touched on this earlier, but about individual differences, but I'll just ask it again. And my question is, how do these differences, such as musical training, uh, influence rhythm processing or recovery after neural disruption?
So a lot of studies we do, we also this for gait studies that we run, we generally recruit different groups of people as participants. We recruit younger adults. Sometimes we recruit older age-matched adults who are healthy, and match them with those who have Parkinson's disease. One of the some of the tests that we give them, one is the like a beat perception task, where we determine their abilities of how well they are able to both recognize a beat and also replicate it after hearing it. We also ask about their musical sophistication, which is just a way of saying how important is music in your life? How often do you interact with it? How much are you listening to music? How much training do you have in musical things such as playing an instrument or singing or dancing and so on? So, as far as simply the training and abilities goes, studies have found that those with musical training are able to retain their beat perception abilities even after developing Parkinson's disease compared to healthy controls. But those who do not have musical training and then develop Parkinson's have significantly worse beat perception and behavior compared to match controls. So it's essentially a way of saying that if you have training, it will help help you maintain your abilities in the future compared to if you don't. Now, talking about other specific aspects that we look at when we're testing this rhythmic auditory cueing, which is the general term for it, we look at things such as familiarity. So, how much does knowing a song affect it? How much you like the song you're hearing, and how much groove it has. Groove being an actual term for how much music makes you want to move, whether that's bobbing your head or stepping or dancing. High groove songs actually do work better as treatment in this rhythmic auditory cueing, where the stronger the beat, the more it, or, and the song in general, the more it makes you want to move, the better the effects on your gait and balance parameters. However, we are right now, it's unclear whether higher beat perception in those with Parkinson's does then improve the actual outcomes of the study. Some have found that higher beat perception abilities don't have a significant effect on um, responsiveness to the treatment, but this is ongoing. And even now, we're still developing new ways to test this, new types of music, whether, again, like I said, whether familiarity or liking a song has better effects, and everything that we can kind of put together to improve this treatment. Because generally, um, a lot of those with Parkinson's will also be receiving medication, dopaminergic medication, that to help with the chemical aspect of the disease. But as a supplement, being able to have this musical addition, which is very inexpensive, it's very accessible, it's something you can do at home. You don't need to go into the doctor. Anything we can do to develop methods that can be used more widely and easily
Yeah.
is always a huge bonus.
Thank you. And looking ahead, what do you see as the most important open questions about how rhythm and movement interact in the brain from your research?
Mm. Yeah, so there are so many different aspects of how music affects us. We've mainly been talking about the beat and how that can help, but we also, of course, know that music has a strong effect on your memories. We've done studies that look at how familiar music is perhaps able to evoke more memories of your own past than unfamiliar music, looking at essentially the most popular songs from the decade where you were in your formative years. We look at music that's popular when you're a child versus when you're a teenager and a young adult versus when you're, an older adult and aging. And we're looking at kind of the critical period of music you hear in generally your teens, roughly, is often, more intensely ingrained in your memory and is
Your
able to kind of
teenagers?
work. Uh, yes. So generally, yeah, the formative years of like music you're hearing, like when you're developing your sense of self generally, right? Like preteen, teenage, and then early
Oh
20s.
wow. I didn't know that. Yeah.
Yeah, that's one thing that. we look at as well. Um, in my research that is ongoing, we're looking at how the perception and the effect of feeling the emotion that is conveyed in music can then affect how you are conveying emotion when you're uh, producing music and how you're able to better synchronize with people you're playing with and also people who are hearing you. So at a concert, how are you best able to convey emotion through music from yourself to your audience? And what does that look like in the brain? And if you are more successful at that, does that result in higher synchronization between your brains, higher neural synchrony or not? That's something that's currently being investigated. So taking that as aspects of kind of this holistic approach to music in, areas of your life, whether it be listening or producing it or your memories of it, all of that together, how are we looking to develop these methods to, better help people, learn, but then also um, result in better treatments and outcomes for things such as Parkinson's.
Wow, thank you so much for meeting me today. I think that's all the questions that I had for you. I really appreciate you taking the time out to come here and meet with me. It was really interesting. I learned a lot, and yeah, thank you so much. I'm just going to pause the recording here.